Alright guys, we're going to take a look at another math notes today. This is math notes 3.1.4. Pi math notes. Actually, this has nothing to do with pi. We're going to talk about the formal definition of rigid transformations. In chapter 1, you learn that a function assigns each input to a unique output. Most of these functions involve equations such as f of x equals 3x minus 5. So if you plug in a 2, f of 2 equals 1. In this chapter, you're studying functions that assign each point in the plane to a unique image point in the plane. These functions are called rigid transformations or motions because they move the entire plane, the entire sheet of tracing paper, with any figures you have drawn so that all the figure remains unchanged. That's why it's called rigid. They're not stretching in any way, right? Therefore, angle measurements and segment lengths are preserved. We keep the x and y axes on the underlying plane in their original position for reference. So we're just moving stuff around on the coordinate plane here. And we're going to talk about three ways that we can move it. There's three basic rigid transformations that we will consider: reflections, translations, and rotation. And all rigid transformations can be seen as a combination of those three. First one we're going to talk about here is reflections. So when an image is reflected across a line of reflection, such as the figure at the right, this guy right here, it appears that the image is flipped over the line, looking like a mirror image. The mirror line is a line of reflection. So this line of reflection is this dotted line right here, shown as line L in the diagram. However, formally, a reflection across a line of reflection is defined as a function of each point A to a unique image point A prime, so that the segment connecting the points and their images, such as A prime, is perpendicular to the line of reflection, and so that the segment AP has the same length as segment AP prime. Well, that's a lot of words. What that means here is that if we take a look at this line that goes from point A to point A prime, that this distance here on the left of the line of reflections, if it was 2 centimeters, say, then on the right it would also be 2 centimeters, and that those distances are equal for any points in the figure. So if I were to connect here, if there was, say, a point B here and a B prime over here, and I came and connected those with a line that went perpendicular means crosses at 90 degrees to my line of reflection, then those, and let's add another point here. Why don't we call this D? So BD, this length here, would be the same length as DB prime. So if this length was, say, I don't know, we're just making stuff up here, 3 centimeters, that this length would also be 3 centimeters. So they're all equidistant from that line of symmetry. And if we were to come in here, same, and have a C and a C prime, draw those connections, and these would each, say, be 1 centimeter away from each other, something like that. All right? But you can also just imagine it as being flipped over the line, or even folding your paper at this line of symmetry, and if they are reflected, they should land on top of each other. So the next one we're going to talk about is rotations. Rotations are turning a figure about a fixed point. Figures can be rotated either clockwise or counterclockwise. If you get confused about what clockwise, or which direction is clockwise and which direction is counterclockwise, the easiest thing to do is find an analog clock, usually hanging on the wall in one of your classrooms, and you'll notice that the second hand is going around in the direction shown in the clockwise, and that is where the word comes from. So if it's traveling like a second hand or minute hand or an hour hand on a clock, then it is going clockwise. If it's going the opposite direction, it is counterclockwise. Formally, a rotation about point O is a function that assigns each point P in the plane a unique image point, P prime, so that all angles of rotation, angle P, O, P prime, have the same measure, which is the angle of rotation. So again, let's talk about what that means. If we think about this as our point of rotation down here, point O, and we have a line that's coming off of it, it goes out to point P, and another line that goes out to point P prime, which I'll adjust here in a second. Then the angle formed there is the angle of rotation. So for instance, if this is, say, 20 degrees, then we have rotated this figure 20 degrees clockwise around point O, or about point O is how we say it sometimes. So 20 degrees clockwise about point O. And the whole figure has been rotated 20 degrees clockwise. So if I were to come in here, let me see if I can do this. If I can trace this and rotate this whole thing here. Let's see if it'll rotate for me. The board's not behaving super well today. So this other point, that's sort of close. I want to be Q, so this could be Q and this could be Q prime. That's also rotated 20 degrees. That angle of rotations is the same for all the points in the figure. So it's still being rotated 20 degrees around point O. You can think of that sort of like a fan blade, where the point of rotation is the center of the fan blade. All right, last one we're going to talk about are translations. Translations are probably the simplest transformation. A transformation or translation is just sliding a figure. So nothing rotates, nothing flips. We're just going to slide it. Up stays up, down stays down, left stays left, and right stays right. A translation is a function that assigns each point Q in the plane a unique image point Q prime, so that all set line segments connecting a point with its image have equal lengths and are parallel. Okay, so I already used Q up there. Didn't notice it down here. Sorry. So here's our Q. Here's our Q prime. And all we've done is slid this whole figure down and to the right. Now a lot of times we'll break this up and we'll say that we slid it down some amount and then to the right some amount. And if we move each of the points that same amount down and that same amount right, we get a new figure. So this point P would have been down and to the right also. Okay, so guys, those are your three rigid transformations. We had reflections, which were when the image got flipped. We have rotation, which is when it gets turned, and we have translations. On the next slide here, I have 3 problems for you to do. Go ahead and draw this in your notebook. You should have graph paper. So draw triangle ABC there. And I have 3 transformations that I want you to perform on that triangle. The first one is a translation. I want translated 3 left, 2 up. Second one, reflect it over the x-axis, or y equals 0. Third one, rotate it 90 degrees around or about point C. So now your paper should have 4 triangles on it, the original triangle ABC, and then 3 A prime, B prime, C primes that are all translations of that original triangle. Okay guys, pause the video, do your